Betelgeuse, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Betelgeuse is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Betelgeuse. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then, we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we're speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind, but now it starts to slow down, collides with the interstellar wind, and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. You can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes, recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet, 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal, Betelgeuse. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Betelgeuse was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these two forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Betelgeuse right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Betelgeuse will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Betelgeuse will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Betelgeuse is likely to explode at any time in the next 10,000 years, but some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Betelgeuse, there can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. The Betelgeuse black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Betelgeuse is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount, so all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then, the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core. 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
According to a new unpublished study, one of the brightest stars you can see in the night sky is likely to explode within our lifetime. The star in question is a red giant called Betelgeuse. It's located in the left shoulder of the constellation of Orion. The star might have no more than 300 years' worth of fuel left in its core. Once it burns through these last reserves, the core will collapse, forming a black hole. As for the star's outer layers, they are likely to be blasted out into space at a mind-boggling 25,000 miles per second. This is what astronomers call a supernova. If Betelgeuse goes supernova, it will be a spectacular sight to watch from Earth. The star is comparatively not far from our planets, just 650 light-years away. So those layers of ejected gas and dust will shine as bright as the full moon. It will also last for several weeks. Interestingly, most astronomers don't believe Betelgeuse is ready to go kaboom yet. Then what makes the authors of the new paper think otherwise? Well, This star is definitely a red giant that has burned through its primary fuel, hydrogen. At the moment, it's most likely fusing helium remaining in its core into some heavier elements. The point at which a star runs out of its hydrogen is unmissable. When a star is short on hydrogen, it needs to put extra energy into igniting the helium created during the process of hydrogen fusion. These additional efforts make such a star expand dozens of times beyond its original size. It also becomes redder and cooler in the process. Astronomers know that Betelgeuse is very, very large. If you placed it at the center of our solar system, its outer atmosphere would reach so far that it would swallow Jupiter. But it's hard to measure the exact diameter of the star, all because Betelgeuse is not your regular smooth ball of plasma. Instead, it's a lumpy chunk of boiling gas bubbles hiding behind dust clouds. This is the main reason why measuring the size of the star isn't easy. But to determine the star's remaining lifetime, we must know its diameter. And a team of scientists from Japan suggests that Betelgeuse is larger than most astronomers think. The star is known to pulsate. It expands and shrinks, dims and brightens again and again at regular intervals. Researchers link these changes to the periodical expansion of the star's outer region. There are other oddities in the behavior of the star. They appear on a regular basis too. Astronomers see the connection between these quirks and turbulent processes taking place inside the star, which seems ready to go out. The research team behind the new study believes that Betelgeuse's main pulsation mode is represented by the 2,200-day cycle, and the 420-day brightness variation might be the star's secondary quirk. For this scenario to work, Betelgeuse needs to be up to 1/3 wider. And to be as wide as necessary for this model, the star has to be in a later stage of its life, done with burning helium and, instead, running on carbon received from previous fusion of helium atoms. Whether a red giant is burning helium or carbon makes a great difference in terms of how much time it has left. If it's still in its helium-burning phase, the red giant can live for tens of thousands of years. But if it's already in the carbon-burning stage, the end is near and might come within a few thousand years. In the case of Betelgeuse, we can't determine exactly how much carbon the star still has, but carbon exhaustion might happen as soon as in 300 years. After that, fusions of heavier elements might take a few dozens of years. When it's over, the core will collapse and a supernova explosion will occur.
Now tell me, what's the scariest thing in the universe? What, besides Darth Vader and a lightsaber? Well, actually, I was asking about black holes, swallowing anything that comes too close without doubts or regrets. Blinding supernovae, mysterious hypothetical wormholes. Yeah, probably not. Because the most terrifying things in the universe are likely to be rogue planets. Ooh. Nomads, orphans, sunless, unbound. That is what these creepy worlds are called. They have no sun. Unwanted in their star systems, they were once ejected into the soulless emptiness of space. And some of them didn't even have their own star systems. They were born lonely. Rogue planets don't have sunlight. The never-ending night reigns on their surfaces. No light means no warmth, and almost no chance of any kind of life to be able to survive in these frozen worlds. How lonely! Kinda makes you tear up a little. Okay, I'm done. But how do rogue planets get born? When planetary systems, including our solar system, form, it can get messy. Most planets appear from the cosmic dust that is floating in space around a newborn star. And when these planets form, they push one another. This gravitational game of tag often shoves some planets toward the edges of the newly formed star system. And sometimes, one or two of them get ejected from their home altogether. There are also nearby stars that can play with planets too. Stars aren't often born on their own. Clusters of dozens to thousands of stars can appear in space. And in such a crowded environment, it's not a rare occurrence when a star with its own planets steals away a planet or two from another star. After getting a new planet, it can keep it for itself or throw it away into the dark, deep cosmos. Some free-floating planets pop up in a different way, with no parent star to help them. Like stars, they form from collapsed clouds of gas and dust, but since they are too weak, they can't put on enough weight and can't start nuclear reactions that make stars emit light. Such planet-like objects are known as failed stars. Or planets can go rogue after their parent stars disappear. Yes, sometimes stars go out, destroying some of their planets in the process. At the same time, the most distant ones, located in a safer zone, are left more or less intact. But the enormous force of a supernova ejects these planets away from the former star at a tremendous velocity. In any case, astronomers think there may be more rogue planets in our home Milky Way galaxy than anyone ever suspected. A recent simulation has shown there might be billions of them. But the problem is, rogue planets are very hard to detect. It's a tricky feat to find any exoplanet, even when it belongs to a planetary system. After all, planets don't give off their own light like stars. That's why when astronomers want to locate an exoplanet, they look for something blocking the light of its parent star, and it's usually the very planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because there's no parent star and thus there's no light to get dimmer. Another method of detecting exoplanets is the radial velocity method. It detects the planet's gravitational effect on its parent star. But, as you may guess, it doesn't work with rogue planets either. Luckily, there are still some ways we can detect these space wanderers. Imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the light of the star. This makes it appear brighter than usual. The trickiest part is to figure out whether this object is a rogue planet. It's true that the stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there might still be a small parent star invisible because of the glare of the main star. And astronomers have to wait for a long time, sometimes up to a decade, for the main star to move a bit. Then they can finally check if there's also a parent star out there. If there's no parent star in sight, then it's proven the planet is traveling solo. Not apparently. So far, astronomers have identified at least 70 rogue planets or candidate rogue planets. At the same time, we know about more than 5,000 exoplanets in planetary systems. That's a huge gap that proves that detecting rogue planets is a tricky business. Interestingly, free-floating planets might not be as lonesome as we think. They can potentially have moons of their own. They might even take them along when they get pushed out of their cosmic homes. But could a free-roaming world, and possibly its moons, find a new home near a different star? Some experts think it's unlikely. The universe is a very spacious place, and even a large star with an incredible gravitational pull is hardly able to catch a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or even slowing down. Now let's have a look at a rogue planet we have managed to spot. Just 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way galaxy. And even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field, 4 million times stronger than that of our Earth. The exoplanet, with this crazy long name, also produces amazing auroras. When it was discovered a few years ago, astronomers were almost sure they had detected a brown dwarf. This is an object too large to be a planet and too small to be a star. But later, scientists got some evidence that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce such auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. To find more amazing rogue planets, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey using the powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept called Cleopatra, the clever NASA acronym for the Contemporaneous Lensing Parallax and Autonomous Transient Assay. See, I told you it was clever. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. Could Earth one day turn into a frozen sphere aimlessly floating through space? Unlikely. Since our sun isn't going to blow up one day, our world isn't likely to be pushed out of the solar system by our star going supernova. But a rogue planet could cause life on Earth to end. Oh boy. One day, such a space intruder might push Earth out of the habitable zone near the sun and take its place. And our planet would have to retreat to an extreme orbit farther from the sun. The climate all over the planet would start getting colder and colder, turning first half of the planet, then our entire world into an icy desert. There would be a lack of food and other resources. It'd be getting darker and darker. There wouldn't be enough light for planets to get energy. They would wither, and animals that used to feed on them wouldn't be able to find food. Most species would go extinct. The farther our planet would be from the sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Wow, bummer. But hey, don't worry, I guarantee that will never happen. At least, not on my watch.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios. More of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we'd definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain. with many smaller trees, creatures, and its other pieces as its cells. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Mercury gets a bad rap for always being hot, but that's not entirely true. The planet's got no atmosphere, so its temperature swings are wild. When it's facing the sun, it can get up to a blistering 800 degrees Fahrenheit, but when it's turned away, it drops to a frigid minus 290 degrees. The reason for this is that Earth has a cozy atmosphere that keeps our temps in check. Mercury doesn't have that luxury, so it's at the mercy of the sun's rays. But despite all that, Mercury's still worth checking out. It's close to the sun, which makes it a prime spot for studying how solar radiation affects planets. And even though it's not exactly hospitable to life, there are still plenty of mysteries to unravel. Venus is often referred to as the sister planet of Earth. Yeah, many people believe that it's this beautiful and lush planet, just like our home. But boy, are they wrong. In reality, Venus is a total diva. She's got this thick atmosphere that traps heat and causes surface temperatures to reach up to a scorching 864 degrees Fahrenheit. I mean, I get it. Venus wants to stand out and be unique, but she's taken it to a whole new level. She's like that one friend who always has to one-up everyone else. Oh, you think Earth is cool? Well, I'm the only planet that spins clockwise. Beat that. But let's be real here. Venus is just trying too hard. She's got these crazy sulfuric acid clouds that rain down on her surface and make it impossible for anything to survive. It's like she's trying to keep all the attention for herself by making sure no other life forms can exist. And her atmosphere, it's so thick and heavy that it would crush us like a grape. So, yeah, Venus may look pretty from afar with her bright yellowish glow, but don't fall for that. She's a total drama queen who just can't handle sharing the spotlight with anyone else. Anyway, enough about Venus. Let's focus on the real star of the show, Earth. We may not have all the flashy features that Venus has, but at least we're hospitable and welcoming to all forms of life. Plus, we've got pizza. So who needs sulfuric acid clouds anyway? You may think that since we live on this planet, we know it from A to Z, and there is no room for any misconception. Alrighty, then tell me, what shape is Earth? If you say it's round, sorry, but you're not right. So, our planet may look like a ball, but it isn't a perfect one. You see, because of the spinning action, the north and south poles get squished a bit and they're sort of flat. The Earth's wobbling, and other stuff are actually causing it to change shape over time, but it's still roundish. Let's talk about Mars, the red planet that has fascinated humans for centuries. Now, I know we all have this idea that Mars is this habitable planet that we can just pack our bags and move to if Earth becomes uninhabitable. Nope, that's not entirely true. One common misconception about Mars is that it has a breathable atmosphere. While Mars does have an atmosphere, it is much thinner than Earth's and consists mostly of carbon dioxide, making it unsuitable for human life without extensive life support systems. So if you're planning on taking a stroll on the surface of Mars, you better pack your oxygen tanks. But hey, that doesn't mean we should give up on our dreams of colonizing Mars. Who knows? Maybe in a few decades, we'll be able to call Mars our second home. Some people think Jupiter is a solid planet, but let me tell you, that's just a bunch of hot air. Literally. Jupiter is actually a gas giant made up mostly of hydrogen and helium. It's so massive that it doesn't even have a solid surface. I mean, I thought my bed was soft, but floating on a cloud of gas sounds pretty comfy too. Jupiter's atmosphere gradually transitions into its interior, which means it's like a never-ending party in there. Saturn's rings are one of the most fascinating features of the planet. So, a common misconception about Saturn is that its rings are solid. In reality, Saturn's rings are made up of countless small particles of ice and rock that orbit the planet. They stretch out over 174,000 miles from the planet's surface, but are only about 65 feet thick. The particles that make up the rings range in size from tiny specks of dust to large boulders. Scientists believe that the rings were formed from debris left over after the formation of Saturn and its moons. Over time, the particles were pulled in by Saturn's gravity and formed into the beautiful rings we see today. Saturn's rings also have some amazing features, such as gaps and divisions caused by the gravitational pull of nearby moons. There are also waves and spiral patterns that are created by the gravitational interactions between the particles in the rings. Despite their beauty, Saturn's rings are constantly changing. The particles collide with each other, creating new ones and breaking apart others. This means that the rings we see today may look very different in the future. So next time you look up at Saturn and its rings, remember that you're looking at a cosmic snow globe made up of billions of tiny particles floating around the planet. Now, one common misconception about Uranus is that it's a lazy dude who can't even rotate properly. People think it just rolls around on its side all day long, but let me tell you, that's not entirely true. Sure, Uranus does have a tilted axis of rotation, but it still manages to spin in the same direction as most other planets in our solar system. It's like that one friend who always shows up late to the party, but still manages to have a good time and fit in with the crowd. But let's be real, Uranus is still a bit of an oddball. It's the only planet in our solar system that rotates on its side to such a degree. But after all, variety is the spice of life, right? So cheers to Uranus, the planet that refuses to conform to anyone's expectations. Ugh, I wish I had the guts to be like this. Have you ever heard someone say that Neptune is just a blue version of Jupiter or Saturn? Well, let me tell you, that's like saying a banana is just a yellow version of a cucumber. It's not even close. Sure, Neptune and its gas giant buddies share some similarities, but Neptune stands out in the crowd with its beautiful blue hue. It's all thanks to the methane chilling in its atmosphere. By the way, did you know that it's the farthest planet from the Sun? It's so far out there that it takes almost 165 Earth years for it to complete one orbit around the Sun. Talk about taking your sweet time. And let's not forget about its 14 moons. That's right, Neptune has a whole entourage of moons following it around like groupies at a concert. Maybe they're hoping to catch a glimpse of Neptune's famous blue glow. So next time someone tries to tell you that Neptune is just a knockoff version of Jupiter or Saturn, you can confidently correct them and say, "Excuse me, but Neptune is its own unique gas giant with a fancy blue vibe." Did you know that Pluto isn't actually considered a planet anymore? That's right, in 2006, the International Astronomical Union decided to reclassify Pluto as a dwarf planet. So what exactly does that mean? Well, a dwarf planet is a celestial body that orbits the Sun and is big enough to be rounded by its own gravity. But it hasn't cleared its orbit of other debris. It's a common misconception that Pluto is still considered a planet, but the truth is that it's just not big enough to make the cut. Sorry, Pluto. Don't worry though, you may be small, but you're still loved by many. Plus, being a dwarf planet is pretty cool too. You get to hang out with other celestial misfits like Ceres and Haumea. So keep on orbiting, Pluto. We still think you're out of this world.
Now tell me, what's the scariest thing in the universe? What, besides Darth Vader and a lightsaber? Well, actually, I was asking about black holes, swallowing anything that comes too close without doubts or regrets. Blinding supernovae, mysterious hypothetical wormholes. Yeah, probably not. Because the most terrifying things in the universe are likely to be rogue planets. Ooh. Nomads, orphans, sunless, unbound. That is what these creepy worlds are called. They have no sun. Unwanted in their star systems, they were once ejected into the soulless emptiness of space. And some of them didn't even have their own star systems. They were born lonely. Rogue planets don't have sunlight. The never-ending night reigns on their surfaces. No light means no warmth, and almost no chance of any kind of life to be able to survive in these frozen worlds. How lonely! Kinda makes you tear up a little. Okay, I'm done. But how do rogue planets get born? When planetary systems, including our solar system, form, it can get messy. Most planets appear from the cosmic dust that is floating in space around a newborn star. And when these planets form, they push one another. This gravitational game of tag often shoves some planets toward the edges of the newly formed star system. And sometimes, one or two of them get ejected from their home altogether. There are also nearby stars that can play with planets too. Stars aren't often born on their own. Clusters of dozens to thousands of stars can appear in space. And in such a crowded environment, it's not a rare occurrence when a star with its own planets steals away a planet or two from another star. After getting a new planet, it can keep it for itself or throw it away into the dark, deep cosmos. Some free-floating planets pop up in a different way, with no parent star to help them. Like stars, they form from collapsed clouds of gas and dust, but since they are too weak, they can't put on enough weight and can't start nuclear reactions that make stars emit light. Such planet-like objects are known as failed stars. Or planets can go rogue after their parent stars disappear. Yes, sometimes stars go out, destroying some of their planets in the process. At the same time, the most distant ones, located in a safer zone, are left more or less intact. But the enormous force of a supernova ejects these planets away from the former star at a tremendous velocity. In any case, astronomers think there may be more rogue planets in our home Milky Way galaxy than anyone ever suspected. A recent simulation has shown there might be billions of them. But the problem is rogue planets are very hard to detect. You know, it's a tricky feat to find any exoplanet, even when it belongs to a planetary system. After all, planets don't give off their own light like stars. That's why when astronomers want to locate an exoplanet, they look for something blocking the light of its parent star, and it's usually the very planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because there's no parent star and thus there's no light to get dimmer. Another method of detecting exoplanets is the radial velocity method. It detects the planet's gravitational effect on its parent star. But, as you may guess, it doesn't work with rogue planets either. Luckily, there are still some ways we can detect these space wanderers. Imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the light of the star. This makes it appear brighter than usual. The trickiest part is to figure out whether this object is a rogue planet. It's true that the stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there might still be a small parent star invisible because of the glare of the main star. And astronomers have to wait for a long time, sometimes up to a decade, for the main star to move a bit. Then they can finally check if there's also a parent star out there. If there's no parent star in sight, then it's proven the planet is traveling solo. Not apparently. So far, astronomers have identified at least 70 rogue planets or candidate rogue planets. At the same time, we know about more than 5,000 exoplanets in planetary systems. That's a huge gap that proves that detecting rogue planets is a tricky business. Interestingly, free-floating planets might not be as lonesome as we think. They can potentially have moons of their own. They might even take them along when they get pushed out of their cosmic homes. But could a free-roaming world, and possibly its moons, find a new home near a different star? Some experts think it's unlikely. The universe is a very spacious place, and even a large star with an incredible gravitational pull is hardly able to catch a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or even slowing down. Now let's have a look at a rogue planet we have managed to spot. Just 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way galaxy. And even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field, 4 million times stronger than that of our Earth. The exoplanet, with this crazy long name, also produces amazing auroras. When it was discovered a few years ago, astronomers were almost sure they had detected a brown dwarf. This is an object too large to be a planet and too small to be a star. But later, scientists got some evidence that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce such auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. To find more amazing rogue planets, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey using the powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept called Cleopatra, the clever NASA acronym for the Contemporaneous Lensing Parallax and Autonomous Transient Assay. See, I told you it was clever. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. Could Earth one day turn into a frozen sphere aimlessly floating through space? Unlikely. Since our sun isn't going to blow up one day, our world isn't likely to be pushed out of the solar system by our star going supernova. But a rogue planet could cause life on Earth to end. Oh boy. One day, such a space intruder might push Earth out of the habitable zone near the sun and take its place. And our planet would have to retreat to an extreme orbit farther from the sun. The climate all over the planet would start getting colder and colder, turning first half of the planet, then our entire world into an icy desert. There would be a lack of food and other resources. It'd be getting darker and darker. There wouldn't be enough light for planets to get energy. They would wither, and animals that used to feed on them wouldn't be able to find food. Most species would go extinct. The farther our planet would be from the sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Wow, bummer. But hey, don't worry, I guarantee that will never happen. At least, not on my watch. On my watch.
Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song, because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, It has the mass of the Sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our Sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT 14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while, and by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip, we're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So let's keep exploring and keep being amazed by the wonders of The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The Moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the Moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the Moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the Moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the Moon is 400 times smaller than the Sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The Moon won't be able to block the Sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system, but unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.